Namaste guys. Namaste in Hindi means hello. This is Raghav on my next video on Python. In this video we'll be seeing more about Python integers or more generically Python numbers and the arithmetic operations we do on them and the order of the operations performed and so on. Now let's give it a start. So last video we saw about mutable and immutable data types where we found integers or basically numbers in Python are immutable, which means we cannot change the value after allocation. So we don't go to the memory location and change the value, rather we just change the references. So just wanted to show you one more thing along with that. Let's go to idle. So like last time, if I say a equals 10 and I check the ID of a, and b equals 20 and I check the ID of b, both will be different, pointing to two different locations. What if I have a third variable, say c equal to 10? We know that is going to go to the same location as a, right? So I'm saying b equals a. I'm moving the location of b to a2. So ID of a is going to be copied to ID of b right now. Now if I check the IDs, all three will have the same values, right? That's it. All three are going to point to this first location. What about the second location having the value 20 that is left hanging? So I'm saying, say another value r equal to 20 simply, but this is going to be going to that same location as that of the hanging space, just to prevent duplicates, and Python takes care of all these. We don't have to check it out. That's it. So it's the same as b, and all these allocations are based on keeping in mind the speed of access. So Python doesn't care of memory wastages as much, it just wants speed. So in this case it's going to be the same speed. Rather than creating a duplicate, it just goes and points to the hanging space. So let me show you that with an example here diagrammatically. So again, like last time, we have a variable a here with a value 10 and a value b, 20 for b, and after a equals b, the reference value a will be pointing to b's location, and this will be left idle. And if I have a third variable, say c equal to 10, it will come back and point to the same hanging space. This is what we just saw there, and that's it. So let's get into the story of Python numbers right now. So basically Python numbers are numerical data which are stored in two different data types in Python 3, which are integers and floats. As we all know, integers are nothing but numbers with whole numbers with a sign. Say the syntax is important, I'll tell you later about that. So a equals 10 is an integer variable a. Let's check the type. Type of a is a function that gives the type of class. So here it's integer. B equals 10.0, or I'll just, for easiness, let me say f. So type of f should be float. So these are the two number variables or number data types. So yep, let's see the operations performed on them. Let me start with addition. To comment and say this is just a comment for the users, you have to precede it with a hash. So a hash simply says the following line is a comment. So here I just commented addition to just show it out. So right now let me add two integers, say a plus 10. A is an integer and 10 is an integer, so addition of two integers is an integer, which is 20 here. Let me say f plus 10.0. 10.0 is float and f is a float, so float plus float will also be a float, 20.0. What if I add an integer and a float? Any mixed additions or subtraction or multiplication will give you the higher data type. Here the higher data type is a float, so the result will be also a float, 20.0. So then let me go to subtraction, and it will be the same, so there's no much difference. A minus 10 will be an integer, b or f minus 10.0 will be a float, and a minus f would also be a float. 0.0 is a float, 0 is an integer. So yep, that's it about subtraction. Let me try with multiplication. It's going to be the same obviously. So a star 10 is another 100, f star 10.0 is that, a star f is same, so float. These are the basic operations. One more left, which is division. So so far we saw that the higher data type takes the place of the result. So here if it's an integer star integer, we'll get an integer, but in case of division, let me just show it to you. So if I have division of any two numbers, be it integer or a float, or between two integers or between floats, the result will always be a float. Keep that in mind. So let's just say 10 by 2, result is 5, but since it's a float, we'll get a result as 5.0. So what if I say 10 by 3, it's 3.3333. So fully the result is float. So if I say 10.0 by 3, again of course, by 2, again of course it will be a float. So again, so division is, the result is always a float, no matter what. So how about 0 by 1? That will be 0.0. And yep. So what if we want just the digit, or just the whole number instead of decimal, or we don't want the decimal, we just want to drop it. So here if it is 3.333, we want the digit 3 alone. We use floor division for that. Floor division is basically just getting the digit value instead of the decimal. So if I say 10 by 2, I'll get 5.0. If I say 10 double slash by 2, 5, which is an integer. So something like 10 by 3 or 10 double slash by 3 will give me the digit value. That's it. That's about floor division now. What if you want to see the remainder during division of two integers or float or whatever? Python handles it internally. Usually we don't have float moduluses, but we need special functions for that. But Python handles it. Python 3 handles it inbuilt. So let's see about modulus now. So 10 by 2 will be a perfect number, 5.0, without any remainder. So what if I say 10 mod 2? 10 mod 2 will give me the modulus, which is a remainder, which is 0. So 10 mod 2 is going to be perfect. What if I say 10 mod 3.3? It's going to be a float totally. So this can be between two integers as 10 mod 2, or between an integer and a float, or between 10.10 mod 3.9, say it will be 2.3, something like that. So that's what's about modulus. Now what about power? What about exponents basically? So I want to say find out what is 2 squares or 2 power 5 or something like that. There is a special notation for that, which is double star. So if I say 2 double star 3, it will be 2 power 3, which is 8. So I can say 10.0 or 0.5 star 4, which will be a float of course, and 10.10 star 10.10, that will also be a float. So exponents are also handled internally easily. And if I say the type of 2 double star 3 is of course an integer, and if I say the type of 2.0 double star 3 is going to be a float. So this is the same as the number addition, multiplication, subtraction, or the modulus. That's all about arithmetic operations on Python numbers, that is integers and floats. The order of execution works just like the BODMAS, which is bracket open, divide, multiply, add and subtract, like the usual mathematics we use. So let me just go to a new idle, a fresh one. So we are in the order of execution of operations on numbers. Yeah. So let's get in. So I just have, say, a big expression, say 15 plus 2 minus 9 star 100 by 100. I'll get some float value, and obviously it's a float because I have a division involved, and that division is going to happen first based on this rule, BODMAS, which is bracket open, divide, multiply, add and subtract. So you have to just follow the whole expression in this sequence. There's no bracket here, so I won't open it. Let me just make it clear for you right now. How do you execute this? So how is answer 8.0 is? First we open the bracket. There are no brackets here, so forget that. First we perform the divide. That is, the division is here, and the left and right will be the arguments for it. So 100 by 100 is 1. I'm replacing it by 1, and then there's a multiply here. So we multiply 9 star 1 and say it's 9 add then. So there's an addition here which is 17, and 17 minus 9 is 8. Oh, I forgot that 100 by 100 is 1 point. So I'll just do that. 100 by 100 is 1.0, and 9 star 1.0 is 9.0, and 15 plus 2 is 17, and 17 minus 9.0 is 8.0. That's it. So this is how execution is. So if I want to execute, say, 2 minus 9 star 100 first and then the rest, then I use brackets. So the first concept is brackets open, right? So I'll use bracket and say 15 plus bracket open 2 minus 9 star 100 close the bracket by 100. What will this do? This will perform this first. So if I open the bracket, I have to first solve this to open the bracket. How do I solve? Let me just make it clear again. So I'll just copy paste and then solve it. So again, 2 minus 9 star 100 to be executed first. So in this again I perform bracket open, divide, multiply, and add and subtract. So I have a multiply first. I do that and say it's 900. 2 minus 900 is made as 898 or minus 898, and now I open the bracket saying it's minus 898, and minus sign will replace the plus and say it's minus. Now this is the new expression. In this again I perform this and I say divide first. So 898 by 100 is 8.98, and 15 minus 8.98 is 6.02. That's how it's done, and that's the order of execution of any expression. This is how it's done in Python 2, and it's Python 3 and 2 also, and in other languages as well. So let's check out more on the functions that we use for Python numbers, and that in the next video. So yep, that's it for now, I guess. Dhanyawad, and see you again with the next part. Bye bye.